All right, when we are working on these, so 1 through 4, you have to write it with a rational exponent. That means a fraction exponent. This entire thing is under a square root. A square root is what power?
Can I start it in advice again and finish it?
That's fine. Do you want to be in this?
I'm good. I just need to work on the back page, so I won't do the back page. Okay, thank you.
You're welcome. So the whole thing is under a square root. A square root is what power? 1 over 2, right? So remember on those radicals, the index, the little number outside the radical, that's what goes on the denominator. Inside there, I have an x squared times a cube root of x. So a cube root would be what power? Okay, exponent rules. If these are multiplied, the x is written each time, so we add the exponents. So 2 plus 1 over 3 would give us 7 over 3. And that's all to the 1/2. Then if you have a power to a power, what do we do with those exponents? Multiply them. So that's x to the 7/6 power. Oh. Number 4. So I have the cube root of z to the 4th. So what power is that? Times, I have the square root of z, so that's z to the, if those are multiplied, what do we do with the exponents? Add them. So 4/3 plus 1/2 gives us you guys didn't ask about number 1, but a lot of people did yesterday, and I just want to mention something about that one. So when we write this with our exponents, on the top it's the cube root, which we know is x to the 1/3. On the bottom is a square root, which is x to the 1/2. When we divide, bless you, what do we do with those exponents? Subtract. So 1/3 minus 1/2 is negative 1/6. When we had the quiz over this stuff, a lot of people missed this question because they left that as the answer. But the directions say to use positive rational exponents. So how do I rewrite x to the negative 1/6? Remember, negative exponents just change floors. So since I have a negative exponent on the top, it just drops that term down to the bottom. Right, and same thing on number 2. You would have to write it with the negative, without the negative exponents, goes to the bottom. All right, next thing we talked about is domain. Domain is asking what x can be. Right, when I am looking at these, all that really matters is the index on the radical. This is a square root, that one's a cube root. So all we care about is even or odd. Sorry, 5th root. If it is an even, we know if we do the square root of a negative number, what kind of answer do we get? If I do the square root of a negative. Like if, yeah, if I said like the square root of -8, that would have an I in it, right? We only want real values. So if I'm only talking about real values, I can't have negatives under here. So the thing that's under my radical has to be greater than or equal to 0. I don't care about anything on the outside. So I don't care if I'm multiplying by anything, if there's a negative, if I'm adding or subtracting. That doesn't matter. That impacts the range. You know, does my graph move up or down and that kind of thing. But it doesn't affect the domain. So then if I solve this, 9x is greater than or equal to -18. So x is greater than or equal to -2. Now I do expect interval notation at the end. Greater than or equal to -2 is everything bigger than -2. So my answer is bracket because of the equal to, -2 to infinity. Now when I look at number 6, that one is an odd root. If it's an odd, what do we know? Right, you can do the cube root of a negative number or the fifth root of a negative. Those can be anything. So if it's an odd root, there is nothing for you to solve. You just automatically say negative infinity to positive infinity. You guys did not ask about any others on the first page. Take a quick look before we move on. Is there anything else on this first page that you want me to talk about? Let's go to our second page. Make sure you are fixing any of your mistakes as we go through. All right, so 11 through 14, we don't need to work out any of those equations. You guys got them all? Remember, make sure in all these radical equations, what do you have to do at the end? If you add a radical, yeah. But just in general, if you're solving one. So like on questions 7 through 14, what should you have done when you got to the very end? Check your answers. Okay, when you start squaring, sometimes you get numbers that don't really work. So you need to make sure that you are checking all those answers by plugging them back into the original. All right, problem number 15. I want to know if this is one-to-one. There are different ways of doing this. Give me one option. Okay, you do the f of a equals f of b. This is the algebraic way. Did I specify which way to do it? No, I just said figure it out. So I'll show you both ways. If you do this one, we have to solve. If we get a equals b, that means it is one-to-one. Anything else, and it's not. So if you add 6, that's going to get annoying. Then what would we do? How do we get rid of a square? Anytime you add a square root, what do you have to put with that?
Plus or minus.
So automatically, I have a plus 1 equals plus or minus b plus 1. Is this one-to-one then?
No.
No, if you get a plus or minus, it's not. Another option, how else could you have solved this? We know x squared is a parabola. It's been shifted left and down. Okay, I don't need a very accurate graph here. I can see it fails the horizontal line test. So that means it's not one-to-one. Why do we care about one-to-one?
So we know.
Yes, so we know we can find the inverse. So if it's not one-to-one, we can't do the inverse. All right. 16, you guys were okay with. Make sure like f and g are just your parent functions, but when you do h and j, I would expect you to plot the parent function and the final graph. All right, anything else on this page that you would like me to look at? I feel like we don't have very many questions. Does that mean it's going to be a good test? We know what we're doing? That's the plan? Good, good. All right, finding the inverse. This is our 4-step process. What's the first step? You kind of combine the first and second, but that's fine. So f of x is the same thing as y, and we always have to switch the x and y. Okay, now my goal is to solve for y. I have two y's here, so I have to get them on the same side. What do I do first? So those cancel. This gives me xy minus x equals y plus 2. Then what do we do?
Subtract the y and add the x.
We want all the terms with y on one side and all the terms without on the other. So xy minus y equals 2 plus x. Both of these have a y in them, so what do we do? So then to get y by itself, we just divide. So we have 2 plus x over x minus 1. All right, a lot of people caught on that one is the same as the original function. It doesn't happen often, but it can happen. It just means that the original one was symmetric to the line y equals x. So it's rare, but it happens. What's the final step though? Instead of writing y equals, and that's just a notation thing to show that we found the inverse. All right, we know domain and range for the function and the inverse. So that's really 4 things I'm asking you to find. But we know the domain of the function and the range of the inverse are the same. The range of the function and the domain of the inverse are the same. So we really only have to find 2 things. Looking back at the original, what can x not be?
1.
So negative infinity to 1, union 1 to infinity. All right, looking at my inverse, what can x not be? So then we have those. All right, let's look at the next one.
I know you do.
So if I want to find the inverse of this, we change f of x to a y. We switch x and y. And now what do we do? Are you guys following along, correcting any mistakes as we go? Okay. So we get xy plus 2x equals 1. I'm trying to solve for y. Here's the only place that has a y. So we can subtract the 2x. To get y by itself, all I have to do is divide by the x. So instead of y, we put all right, domain of the function is the same as the range of the inverse. What's the domain of the original function? Can't be negative 2. So negative infinity to negative 2, union negative 2 to infinity. All right, range of the function is the same as the domain of the inverse. What can x not be? 0. Negative infinity to 0, union 0 to infinity. All right. Questions there? (22) Anything else on up to that point? 22. We are solving that one. We have a square root over here, which confused a lot of people. Yeah. A square root is the same as what power? Okay. Now we have the same base on each side, so we can drop it. All right, this is like a quadratic. The fraction really threw some people off. What could you do if you really didn't want to deal with the fraction? We could do a decimal, or we could multiply everything by 2 would cancel the 1/2. Did anybody start out squaring both sides of the equation to get rid of the square root? If you had done that, you would have gotten to the same point. So if you had squared both sides, then this becomes 8x squared plus x equals 3 to the first. So you get to the same point. That's another option. All right, so if we slip and slide, what multiplies to -8 and adds to 2? Multiply -8, add to +2.
4 -2.
Okay, we know we have to divide our 8 back as well. So if I set those equal to 0, we get -1/2 and +1/4. On these, you shouldn't be getting answers that don't work, but it doesn't take too long to use your calculator and plug them in to double check yourself. And if you do, it does work out. Is that okay? All right. Back side, looks like fractions and inequalities might be our weak point. That's where we had the most questions. All right, we need to get a common base. Can I really change 2/3? Not really. I can't break down 2 or 3, so I'm just going to leave that for a minute. That means I am hoping to get this side to be a 2/3. All right, so let's look up here. 81. 81 is 3 to the 4th. Okay, 16 is 2 to the 4th. So it's to the 4th, but it's flipped. That's the 3 on top and the 2 on bottom. How do we flip it back? My exponent has to be in -4. So we get 2/3 to the x minus 1 equals 2/3. Power to a power, what do we do with those exponents? Multiply. Now we have the same base on each side, so we can drop the base and set the exponents equal. So if I add over my 4x, add over my 1, and divide, we get -3/5. And again, you can always check these just by plugging them back in. All right, on the inequalities, I told you you can solve them the same way if your base is greater than 1. So all you need to remember on the inequalities to make them work out the same, make sure you set them up so the base is bigger than 1. So would I want to do a base of 2/3? No, you would have to make it 3/2, right? So let's start out just getting common base. 32 and 16, those are both powers of 2. So 32 is 2 to the 5th. 16 is 2 to the 4th. Power to a power, we multiply the exponents. Now, because I chose a base greater than 1, I can just drop the base, bring down the exponents, and keep the inequality the same. So now if I add over my 4x and divide, I get x is less than or equal to 4/9. All right, I do expect, though, anytime we have an inequality problem, I want an interval at the end. So how do we show less than? And since since I had an equal to, that gets a bracket. All right. Let's look at 26 and 27. So, the cube root of 5, how would I rewrite that? Okay. 1/5, how would I write that? So then we multiply our exponents, so we get a negative 1/3 x is less than 5 to the negative x minus 2. So now, because my base is bigger than 1, we can bring down our exponents. If I add over my x, negative 1/3 plus 1 is 2/3. Divide by 2/3, or if you don't like that, you could think multiply by 3/2. You do have to follow inequality rules. If we multiply or divide by a negative, what would happen? We would switch sign, but we're doing a positive here. You guys okay back there? I did. You could have multiplied by 2 or divided by 2/3. That's equivalent. So x is less than negative 3. So that means negative infinity to negative 3. On 27, what do I need to make my base? Can I just do the 5/3?
No. You have to change something.
I'm going to have to change one of them, yeah. Let's keep this one the same because it's our 5/3 is bigger than 1. But we're going to have to change this other one. Okay. So I need it to be 5/3. I know 9, that's 3 squared. 25 is 5 squared, so it's squared, but I need to flip it, so it would be negative 2. So 5/3 to the x greater than or equal to 5/3 to the negative 2 plus 10x. Because my base is bigger than 1, I can drop the base, subtract my 10x. When I divide by negative 9, what happens? So less than or equal to 2/9, so everything smaller would be negative infinity to 2/9 equal to gives me a bracket. So the first one, what'd you use for your common base? Okay, so 16 is 4 squared, 3 squared is 9, so that's 4/3 squared. And we still have the x minus 3. Okay, over here. This is 4/3 to what power? It has to be a negative 3. 3 to the third is 27, 4 to the third is 64, but we need to flip it. So that means 4/3 to the 2x minus 6 equals 4/3 to the negative 9x minus 3. So if we set the exponents equal, so we get 11x equals 3, so 3/11. B. How do I do a problem like that? Well, we have to bring over the 12. And then it's no longer, I don't have a GCF, do I? So what do we have to do here? Well, I can't take it out, but I think you're saying the right thing, or meaning the right thing, just saying it differently. This is like a quadratic, right? Does everybody see this? So we have the 2/3, we have half of that is 1/3, and we have a constant. So x to the 2/3 would break into x to the 1/3. What multiplies to -12 and adds to -1? So x to the 1/3, that means the cube root of x. So we get the cube root of x is 4, the cube root of x is 3. So then how do you solve those? Third power. So 4 to the third is 64. -3 to the third is -27. Did you guys get that one? C. What would I do? 6x to the -2, that means 6 over x squared, minus 13x to the -1, so 13 over x, plus 5 equals 0. So what do we do? So we get 6 minus 13x plus 5x squared equals 0. Or we can turn that around. So then how do we solve that? Multiply to 30 and add to -13. Okay, we divide our 5 back. So we get 2 3/5. And of course, we can always check those, plugging them back in, and you should be taking the time to do that. All right, are those okay? Do you want a couple more problems? Are we okay on the interest ones?
Can you like these ones?
The rational ones, yes.
Are the interest formulas gonna be on the test?
Yes, I will give you the formulas. All right, I'll put 3 questions up here, and that'll probably be the end for today. Let's go ahead and just walk through these together since we don't have a ton of time. What would we have to do first on D? Good. Always isolate your radical first. Okay, and then how do we cancel a square root? How do I do 3x plus 1 squared? Okay, so if I get this equal to 0, if I subtract my 4x, subtract my 1, then what would we do? So if we set those equal to 0, we get 0 and we have 2 9s. And then what do we have to do?
Sub it back in.
You have to check this. Are you guys okay if I skip the checking step? I don't really know which, or might be both of them, maybe neither. I don't really know when we check them, but you guys could do that. I know the 0 should work. I don't know about the -2 9s. All right, finding the inverse. What do we do? And then what do we do? Switch our x on 1. Okay, so if we multiply over the y, add multiple y's, so we need them on the same side. Take out the y. So then we divide it, and at the end, instead of writing y, we say f inverse of x. Domain of the function is the same as the range of the inverse. What's the domain of the original function? Can't be 0. Right. The range of the function is the same as the domain of the inverse. Look at your inverse. What can x not be? And the last question, if I ask you to simplify this, the whole thing is under a 5th root. What would I do about that? Well, the power would be 1/5. Okay, inside there, we have an x cubed times the square root of x to the 7th. What do we do with these exponents? So we did 13 halves. And then power to a power, we any questions on those? We have like 2.5 minutes. Is there anything else? Make sure, I can't remember, if you owe me any work from this unit, make sure you get that turned in tomorrow. Cameron, bring me that study guide. I mean, I can print you another copy of the study guide if you wanted to rework the question. Sorry. I just, yeah.
Thank you.
Any of like the old homework.
So I may be gone tomorrow, but I think I'm leaving during advisory to go to like a Meyer implement meal or whatever. So
Okay.
can I go check what time we're leaving for that so I can
Yeah.
start during advisory?
What's that?
It's for everything stuff.
Yeah, they sent out their update for the week, but that's.
So can I go check? So
Yeah.
I can start my day? Yeah. Well, it's like 4 to 6. It's not actually 6. It's close though, which I think is stupid. But nothing we can do about it.
SEL in the cafeteria has been canceled today. There will be no SEL today. Thank you.
I'm sure you guys are upset about
That's our grade, this is?
Yeah.
Darn it. I'm so excited. It's my favorite part of the week. I bet we're talking more. Can I get a charger somewhere?
that. Why don't you just borrow mine?
I'm just going to charge back.
Who has my charger?
I do. It's an Apple charger.
Okay, you're like third in line to go somewhere, that's why I said you have to wait.
Actually, that might be first. We're leaving at 10:45. So
Okay,
we should get back in between the middle and like 12:30. So
okay.
if we're grind and get back and start it and then it's really nice
Well,
actually.
If you're leaving at 10:45, you would be here for all of class. Right? My clock is still an hour behind, I have my clock here. But it's 10:37 right now.
So should I start it right now?
Well, you said you're leaving at 10:45 tomorrow? So you'll
No,
be
today.
today.
But I won't be here tomorrow.
For what?
Contest tomorrow and then today for the Meyer Implements having a customer appreciation meal and they asked that people.
Gotcha. Well, you don't have time to start it right now then. I somehow missed you on the contest.
Well, I just figured out yesterday that I was going, so.
Gotcha, yeah, because you weren't on the contest list that they sent. That's why I was so confused.